Hello everybody, welcome into another lesson. So today we are starting the unit on sequence and series. Today's lesson we will just do an introduction to sequences. When we talk about a sequence, you can think of it as a list or a set of numbers. That's all a sequence is. Here I have a list of numbers 1, 2, 3, 4, 5. Now, you will generally see some formula for a sequence. It's basically a function, that a sub n equals n. So, that a sub n, what that means is I could put in any value from 1 on up. If a domain, which are your inputs, are not specified, it's assumed it starts with 1. And they're going to start with 1 for today's lesson. Unless it specifies otherwise, your domain starts at 1. So a sub 1, I'll just put that 1 in for n, I'll get a value of 1. A sub 2, I'll put the 2 in for n, I'll get a value of 2, and then so on. A sub 3 is 3, a sub 4 is 4, a sub 5 is 5. So those are, what we're doing here is we're listing the terms. We're listing the first 5 terms of the sequence. So let's do some more examples here of listing terms of sequences. Now, let's say the formula for this next sequence was a sub n equals n to the second power. Well, let's find our first term. We're going to list the first 5 terms of the sequence. So let's say we do a sub 1. Well, that's just going to be 1 to the second power, which of course would be 1, right? Then a sub 2, well, that's going to be 2 to the second power, which would give you 4. A sub 3, that would end up being 3 to the second power, which would be 9. Then we have a sub 4, well, that'd be 4 to the second power, which would be 16. And then we can do a sub 5, so that would be 5 to the second power is equal to 25. So the first 5 terms of the sequence are going to be 1, 4, 9, 16, and 25. And then we do another comma, dot, 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 to indicate that the sequence keeps on going, because it'll keep going to infinity. It'll keep going infinitely. But for today's lesson, we're only interested in the first 5 terms of the sequence. Alright, now, what if the term for the sequence was let's say we take the negative of n to the third power. So for this sequence, they want us to take the negative of n to the third power. Well, let's find a sub 1. We're going to list the first 5 terms. So a sub 1, that's going to be equal to negative 1 raised to the third power, which we know would be negative 1. Now let's take a sub 2. Well, that would be negative 2 raised to the third power. That's simply going to equal negative 8. A sub 3, well, that would be negative 3 raised to the third power. That would be negative 27. Let's find a sub 4. Well, that would be negative 4 raised to the third power. So that's going to be negative 64. And then for your 5th term, a sub 5, that would be negative 5 to the third power. Well, that's going to end up being negative 125. So the first 5 terms of your sequence are going to be negative 1, negative 8, negative 27, negative 64, and negative 125. And then dot, 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 because it keeps going to negative infinity. So that's how you list those terms. Let's do 2 more here. Yeah, let's do 2 more. Now, you're not always going to get integers for your sequences. Sometimes you may have a formula such as this: a sub n equals n plus 2 over 2n. So a sub n equals n plus 2 over 2n. That's a formula for the nth term of a sequence. If I wanted to find the 100th term, I could just put in 100 for n. I would get 102 over 200, which would reduce to 51 out of 100, of course. That would be the 100th term of the sequence. But we're only doing the first 5. So a sub 1, well, that's going to be equal to 1 plus 2 over 2 times 1, which would be equal to 3 over 2. Now let's do a sub 2. So that would be equal to 2 plus 2 over 2 times 2, which would be equal to 4 over 4, which equals 1. Now what about a sub 3? So that's equal to 3 plus 2 over 2 times 3. Well, that's going to equal 5 over 6. A sub 4 would equal 4 plus 2 over 2 times 4, which would end up giving you 6 over 8, which we know reduces to 3/4. And then your a sub 5 would be equal to 5 plus 2 over 2 times 5, which would turn into 7/10. Alright, so we can write the first 5 terms of the sequence being 3/2, 1, 5/6, 3/4, and then 7/10. So those are the first 5 terms of the sequence, and then obviously it's just going to keep on going and going. And I got one more for listing terms, then we're going to work backwards, so to say. Now this one is a sub n equals negative 3 divided by n. So a sub n equals negative 3 divided by n. So we'll do the first 5 terms. So a sub 1 would equal negative 3 over 1, which we know is just simply negative 3. A sub 2, that's going to be negative 3 over 2. A sub 3, well, that would be negative 3 over 3, which would turn into negative 1. A sub 4, that would be negative 3/4. And then a sub 5, that would end up being negative 3/5. So the first 5 terms of the sequence are going to be negative 3, negative 3/2, negative 1, negative 3/4, and then negative 3/5. And of course, it'll just keep on going and going. Those are the first 5 terms of this sequence. Alright, so that's easy enough listing terms of a sequence, just plugging whatever value in you're trying to find for whatever term of the sequence into your function there, you got your value. Real easy. Now, let's work backwards. We're going to list a sequence here. So 1, 3, 5, 7, ... We have 4 terms of a sequence. First thing we want to do is figure out what would the next term be. So what is the next term? See if you can spot a pattern. So you have 1, 3, 5, and 7. You notice between each term you're just adding 2, right? So that would mean your 5th term, a sub 5, that would be 9. So your 5th term is going to be 9 then. Alright, now, the next thing we want to do is write a general formula for the terms of the sequence. Usually to do that, you take your very first number that you got, which is 1. So we got 1. Now, you're going to do plus, you have, it's 2 more, right? if I took 2 times n minus 1, all right, so for example, right, so my n is 1 for the first number. Well, 1 minus 1 is 0. 2 times 0 is 0. I get 1. And you can put these values back in to check your work. Let's say I want to get a sub 2. So that would be 1 plus 2 times 2 minus 1, which would end up giving you 1 plus 2 times 1, which is 1 plus 2. That gives you 3. So it sure seems to hold there, right? Let's do a sub 3. So that's going to end up equaling 1 plus 2 times 3 minus 1. So that would equal 1 plus 2 times 2, which is 1 plus 4. That equals 5. So yes, that actually does seem to hold then. So we have, of course, now we can say a sub n equals 1 plus 2 times the quantity of n minus 1, which would simplify into 1 plus 2n minus 2. And truthfully, we could say then that a sub n equals 2n minus 1. So we end up getting then that the fifth term is 9, and the general term for the nth term of the sequence is going to be a sub n equals 2n minus 1 once we simplify. All right, let's do another example here. We have 1, 10, 100, 1,000, ... Okay, so we have 4 terms in a sequence again here. We have 1, 10, 100, and 1,000. So do we notice a pattern? They seem to, every number you seem to multiply by 10. You seem to keep going up and up and up and multiplying by 10. So what would the fifth number of the sequence be if we were to continue that trend of multiplying by 10? It would be 10,000, right? So that means the next term of the sequence, the fifth number, should be 10,000 if we're asked to find the missing number of the sequence. Now, we need to come up with a general formula for the nth term of a sequence. So, of course, you're going to have your a sub n denoting the nth term of the sequence. Now, these all multiply by 10, right? If these multiply by 10, couldn't we just say 10 to a power? So, for example, if I did 10 to the n minus 1 power, well, let's put in 1 for n. Well, that would be 10 to the 0. That gives you 1. If I want to find the second term, I would then put in 2 for n. I would get 10 to the first, gives me 10. If I want to find the third term, I'd put in 3 for n. I would get 10 to the second. I get 100. So you see, this really does work. So the general formula is going to be a sub n equals 10 to the n minus 1. And in a couple lessons, we'll get into an example of what is called a geometric sequence, which this is actually what it is a geometric sequence. The previous example we did was actually an arithmetic sequence. This is a geometric sequence. But today we're just doing sequences in general. It's kind of a mix of all of them. And then some sequences that don't qualify as either one. That's another important thing. Alright, now this one's a bit of a doozy. 2, -4, 8. -10, +14. So this one looks a bit scary, doesn't it? Okay. So we have 2, -4, 8, -10, +14. So what the heck is going on with this sequence? Well, you notice here, let me write in a different color for this maybe. We notice here, from here to here, you subtract 6, right? And then from -4 to 8, you're actually adding 12. Now, from 8 to -10, you are subtracting 18, and then from negative 10 to 14, you're adding 24. So you notice you're alternating positive and negative in multiples of 6, right? First you subtract 6, then you add 12, then you subtract 18, then you add 24. If we want to find the very next number of the sequence, which in this case would be the 6th number of the sequence, if the pattern holds, that means we'd subtract 30. So if we take 14 minus 30, we should get negative 16 based on the pattern. So the next term of the sequence should end up being negative 16. Now, how do we go about finding a formula for this mess? Well, take your first term of 2. You got your first term of 2. Now, this is going to end up being, let's see here. So this would be 2 plus. Now, you're going to have a negative 1. And I'll explain this here in a second. Here, hold on a second. Let me get this. So, let me explain what we're doing here. So, your first term is 2. Now notice you have the alternating positive and negative pattern. If you just want to find your first term of the sequence, right, you'll put in that 1 for the negative 1 to the n minus 1, you'll get negative 1 to the 0 power, which becomes positive 1. And then you'll actually have 6 times n minus 1. That's probably an important thing to denote too. I should probably put brackets here. 6 times n minus 1. So this will be 2 plus negative 1 to the n minus 1 power times the quantity of 6 times n minus 1. So if I take n minus 1 here for the negative 1, that would be negative 1 to the 0, which is positive 1. Then if I put 1 in here for 6 times n minus 1, I'll get 6 times 0, which is 0. I just get out 2 for my first term, right? Alright, so what if now I want to find my second term? I take 2 plus that negative 1 to the 2 minus 1 times that 6 times 2 minus 1. And what do you know? You're going to get 2 plus, that would be negative 1 to the first, which is simply negative 1 times 6. So that would be 2 minus 6, which gives you, what do you know? Negative 4. You get a second term of negative 4, right? Let's try it for the third term, see what happens. Alright, so let's find the third term. So, again, my first term is 2, plus I'll take that negative 1. This time it's going to be to the 3 minus 1 times the quantity of 6 times 3 minus 1. Yeah, I need to make an adjustment to this here. Alright, so really this should actually be a sub n equals a a sub n minus 1. So this is going to be your previous term, which is actually, in this case, to find the third term, I'll take negative 4 plus negative 1 to the 3 minus 1. Well, what's that? 3 minus 1 is 2. Negative 1 squared is actually positive 1. And then 3 minus 2 in the parentheses is 2, so I would actually have negative 4 plus 12, which gives me positive 8. Now let's say I want to take a sub 4. So that's going to then be, of course, take your previous term, that a sub n minus 1, which would be your a sub 3, which is your 8. So that's going to be 8 plus that negative 1 to the 4 minus 1 times the quantity of 6 times the quantity of 4 minus 1. All right? Well, you'll have 8, but what is negative 1 to the 4 minus 1? That's negative 1 to the third, which would actually be minus 1. So you'll have 8 minus 1 times 6 times 3, which would give you 8 minus 18, which gives you negative 10 for your fourth term. So in this case, to find the next term, you have to take the previous term. So a sub n equals a sub n minus 1 plus that negative 1 to the n minus 1 times the quantity of 6 times n minus 1. So why that negative 1? Whenever you have alternating signs in a sequence, you're always going to do a negative 1 to some n power. If your first term is positive, it's always going to be to the n minus 1 or the n plus 1, depending upon which way you want to go with it. Either case could actually work, honestly. And then you'll, of course, have what the pattern is for being added slash subtracted, that multiple of 6 times your number minus 1. Now, if your first term was negative, it would just be negative 1 to the n power as opposed to n minus 1. So it's being able to basically draw a pattern, see what comes next, and seeing if you can draw a good conclusion about what the general formula is going to be for a sequence. All right. Here we go. Negative 5, 10, negative 15, 20, ... Okay. So we have negative 5, 10, negative 15, positive 20. So again, it's alternating positive and negative. But notice they all still seem to be in multiples of 5, don't they? So the next one, if we want to get the fifth term of the sequence, it's going to be a negative since it alternates positive and negative, and you should get negative 25 total for your fifth term. So the next term should be negative 25. If we wanted the one after that, it would be positive 30. All right, so now we need to find the formula for the general term for any term of the sequence. Okay. Well, notice we have the negatives. It's alternating positive and negative. So you're definitely going to have negative 1 to some power. Now your first term is negative, right? So if you take negative 1 to the n power, set negative 1 to the first, you get negative 1, right? So that part checks out. Now you also are going to have, it looks like there's a common multiple of 5. So you'll take 5 times n. There's a difference of 5. Between each, a common multiple of 5. So if I take 5 times 1 for this, I would get 5, and I would get the negative 5 if I took negative 1 to the first. Now if I want to get the second term, I take negative 1 to the second, I'll get positive 1 times 5 times 2, that'd be positive 10. Take negative 1 to the third to get the third term, I would get negative 1 times 5 times 3, well that'd give me negative 15. So the general formula for any term of the sequence is going to be a sub n equals negative 1 to the n power times 5n. Alright, this one's not so bad. Negative 1/4, negative 1/2, negative 1/4, negative 1/6, negative 1/8, yada, yada, yada. Okay. So 4 terms of a sequence are given. Negative 1/2, negative 1/4, negative 1/6, negative 1/8. Well, what would probably be the next term of the sequence? We notice that the numerator's staying the same, negative 1. So let's find the 5th term. We know the numerator is going to be negative 1, that much is a given. But the denominator increases by 2 for each one, right? So that means the next term should be negative 1/10. That's exactly what we should get for the 5th term, would be negative 1/10. Now, how can we write a formula for the sequence? So that'd be a sub n. Well, your numerator, no matter what's negative 1, so use that. You'll have negative 1 in your numerator. And now notice your denominator is just all multiples of 2. So that'd be negative 1 over 2n. If I put in 1, I'll get negative 1/2. If I put in 3, I'll get negative 1/6. So this formula does check out. So the formula for this sequence will be a sub n equals negative 1 over 2n. That one wasn't so bad. Now, let's see, we have 1/4, 2/5, 3/6, 4/7, and 5/8. Alright, so we have the sequence here. The first 5 terms are given. We have 1/4, 2/5, 3/6, 4/7, 5/8. We need to find, first let's find the 6th term. So notice the numerator keeps going up by 1 number, right? So that means we'll definitely have a 6 for the numerator. Now notice your denominator starts at 4, but it still goes up by 1 number. So you should get 6/9, which really means your 6th term, if you reduce it, should be 2/3. And it's usually best to reduce it. You should end up getting 2/3 for your 6th term, which is 6/9. Now, let's find the formula for the general nth term of the sequence. So that's going to be, again, a sub n would equal, well, your numerator keeps increasing by 1 number, and it starts at 1 for your first number, so that's just going to be n in your numerator. Just literally input n, you'll get your numerator. Now, it starts at 4 in the numerator, but still goes up by 1. Well, 4 minus 1 is 3, right? So this would be n over n plus 3. So if I want to find the 5th term, I would get 5 over 8, which I have right here. So just testing out some values, and it holds up. So the general formula for the nth term of the sequence is a sub n equals n over n plus 3. All right. I have 3 more. All right, this one should be easy. 1/3, 2/3, 3/3, 4/3, 5/3, ... Okay. So we have another sequence with 5 terms. 1/3, 2/3, 3/3. I don't know where I got 4/5. That was 4/3. My bad. Ugh. 4/3 and 5/3. So let's find the next term, which would be the 6th term. Well, according to the pattern, your denominator is going to stay 3, but your numerator keeps going up by 1 number, so a sub 6 would equal 6/3, better known as 2, right? So your 6th term would be the whole number 2. Now let's find a formula for the nth term of the sequence. Well, Definitely a denominator of 3. That doesn't change for any of them, right? And honestly, your numerator just keeps going up by 1 for every number you put in, so the general formula for the nth term of the sequence would be a sub n equals n over 3. I got about 2 more, then we're done for the day. Alright, let's see. We have 1/9, 2/8, 3/7, 4/6, ... So here's a sequence here with 1/9, 2/8, 3/7, 4/6. So let's look at our numerator. We're going to find the 5th term, right? The 5th term, well, notice the numerator keeps going up by 1. So it's literally going to be n. It'll be whatever that number is for the current term you're on will be your numerator. Whoops, I'm thinking of the recursive. Well, that's true. If it increases by 1 in your numerator, that means your numerator should in fact be 5. Now what about your denominator? Well, it starts at 9, but it keeps going down by 1 unit, right? If the pattern continues for the 5th number, it should end up being 5 in the denominator also. So a sub 5 should equal 5 over 5, which actually means that a sub 5 should equal 1. That would be your 5th term, would be the whole number 1. Now, let's find the recursive formula it's called, or, well, we'll get to that later. Let's just call this the general formula for the nth term of the sequence. So your numerator just goes up, it basically whatever number of term you're on, that's the number of your numerator. It goes up by 1 number for each one. So you'll have n in the numerator. Now, in the denominator, you start at 9, but you end up with, you go down by 1, but you start at 9. So, let's see here. Definitely going to reflect that we're starting at 9. It's going to be 9 minus, now, that'd be 9 minus n minus 1. So let's see, 9 minus n plus 1. Which would work. So this would give us the general formula would be n over 10 minus n. Now how do we figure that out? Well, the first term of the denominator is 9. Now, let's say we wanted to get the second term, right? So I put in 2 in the numerator. Well, I would get 9 minus the quantity of 2 minus 1. That would give me 9 minus 1, which is 8. I want to find the third term, so I'll take 3 over 9 minus the quantity of 3 minus 1. So that'd be 3 over 9 minus 2. Well, that'd be 3 over 7. So that's where the n over 9 minus the quantity of n minus 1 comes from. So this simplifies into the general nth term of the formula. The formula for that is going to be a sub n equals n over 10 minus n. And I got one more. All right. We got 1.9, 2.7, 3.5, 4.3, 5.1, yada, yada, yada. Okay. So we have 1.9, 2.7, 3.5, 4.3, 5.1. So notice it just between each number keeps going up by 0.8. So we have 5 terms, let's find the 6th term. If it keeps going up by 0.8, that means the next term should be 5.9. So your sixth term should end up being 5.9. Okay, now we need to find a general formula for the nth term of the sequence. Start with the fact that your first term is 1.9, okay? Now, the first term is 1.9. Well, notice it keeps going up by 0.8. That should be plus 0.8 times n. So if I put in 1 for n to get my... Actually, that'd be 0.8 times n minus 1, excuse me. So if I put in 1 for n, I would get 0 here, get 1.9. Now if I put in 2 for n, I would get 1.9 plus 0.8 gives me 2.7. Put in 3, I would end up getting 1.9 plus 1.6, that would give me 3.5. But we can simplify this formula a little bit. If we distribute that 0.8, you'll get 1.9 plus 0.8n minus 1, which actually means a sub n would equal 0.8n plus 0.9. But always start with your first number if they go by a common difference. If there's a common difference between them, start with your first number and then take that common difference, multiply it by whether it's going to be, and usually it's going to be that number minus 1. That's usually what it's going to be. And then you can just do the distribution and simplify it. So the general formula for the nth term of the sequence is 0.8n plus 0.9. And this would be a term of an arithmetic sequence because it has a common difference. But we will have a separate lesson just for arithmetic sequences. We'll go into more details. Today was just an introduction to sequences. Now, the next lesson we are going to do introduction to series, which builds off sequences, but series are... It's a step up. It's a little bit different. It's actually quite a bit different, but it does take what we've learned today and applies it. So I do hope everyone has a great night. Take care.